Lesson 5.4 takes a little bit from Chapter 4. In this lesson, we're going to factor and solve polynomial equations. Let's start off with some basic factoring review from Chapter 4. In our first example, we have 8x squared plus 20x. If the constant is missing, we're going to check for a common factor. Take a look at 8x squared and 20x. Do you notice anything that we could factor out of both of those terms as a common factor? Starting with the coefficients 8 and 20, I know we can take a 4 out of both of those numbers. And then because there's an x squared and an x term, we can factor x out. Our goal is to see what's left over. If we factor 4x out of 8x squared, we would have 2 times x left over. And then there's a plus. And if we take 4x out of 20x, we would have 5. The product 4x times 2x plus 5 is factored. Now the next one, x squared plus 7x plus 12, we've actually seen this one before. When there is a constant and no common factor, we want to find values that multiply to get 12 or factors of 12 that add to get 7. Hopefully you recognize that 3 and 4 would multiply to get 12 and also add to get 7. That means we take our x squared and we split it into two parts, x times x. And since 3 and 4 are both positive, to multiply to equal positive 12 and add to get positive 7, we literally just write plus 3 and plus 4. And that's factored. Now the next one, it's same idea as this one. X squared minus 8x plus 16. Numbers that multiply to get 16, we could do 1 and 16, we could do 2 and 8, and we can do 4 and 4. Now which pair would give us negative 8 in the middle? I'm going to erase that though so I have enough room. That would be 4 and 4, but they both would have to be negative. Making x squared separate into x times x, minus 4 and minus 4. Or you can write it as that perfect square, x minus 4 squared. All right, let's try some down below. We're just going to keep kind of doing this little review before we move on to the next part of the lesson. Now, here's the thing with the next example, x squared plus 6. We only have two terms. The 0 term in the middle is missing. There's no common factor, so if we split that up into x squared plus, or not split it up, sorry, rewrite it as x squared plus 0x plus 6, there aren't two numbers that break down to get positive 6 and also add to get 0 in the middle. So this one as is doesn't break down any further. It's not factorable. Here's the difference though. Look at the next one. X squared minus 9. Remember when we had a difference of two squares back in chapter 4? If we introduce that 0x term now, we actually can break down 9 into positive 3 and negative 3. That would multiply to get negative 9, but then they would add to get 0 in the middle. So x squared is going to break down into x times x. And then we have minus 3 and plus 3. And you can write those in either order. Now it gets a little trickier with that 4x squared minus 25. Here if we add that 0x in the middle, we would have 4x squared plus 0x minus 25. I'm going to have to slide this over so I have a little bit more room to work. There we go. The a value is 4, which means we have to do a times c. 4 times negative 25 is negative 100. Now what could we split negative 100 into with two factors that multiply to get negative 100 but add to get 0 in the middle? We would have to use positive 10 and negative 10. So when I split that b value, I'm going to put the negative first, negative 10x plus 10x. Technically, they cancel out to get 0 in the middle, which is what we wanted. But this is one of those factor rules, everyone, where we have to drop down the first term and drop down the last term. If we group the first two and then group the second two, 4x squared minus 10x, we could take a 2 and an x out of both of them. And that would give us 2x minus 5. And then in that second parenthesis, 10x minus 25, I know 5 can be taken out of both of those coefficients. 5 goes into 10x, we'd have 2 times x left over. And 5 goes into 25, there's 5 again. Notice our parentheses match, so that's one factor. Watch your pluses and minuses here. And then if I take the two parts that are left over on the outside, I've got that 2x and the plain 5. Technically, that's positive right there. That would be 2x plus 5. This is also an example of a difference of two squares, but putting that 0x term in the middle and applying the a times c rule gets you that same result. As we work with these higher ordered polynomials, if you're asked to factor completely, it means you're going to want to write your polynomial as a product of smaller, unfactorable parts. And what I mean by that is nothing can be broken down further in the parentheses. Let's take a look at how this works. Factoring higher ordered polynomials. We're always going to want to start off by looking for a common factor. So let's kind of add that in. Just write common factor first. Sometimes we have them and sometimes we don't. We just have to check. All right, let's take a look. X cubed plus 2x squared minus 15x. This is an example of a cubic expression. Take a look at those three terms and notice they do have an x in common. There's an x in all three of them. That's a common factor. If we take that out, we're left with x squared plus 2x minus 15. And now that is quadratic. And we're going to follow our rules from up above to see if we can break that down. Can you think of two numbers that multiply to get negative 15? I know we could use 1 and 15 or 3 and 5. But is there a way to multiply them to equal negative 15 and also add to get positive 2? If we use positive 5 and negative 3, that would give us positive 2 when we add. The x on the outside is part of our answer. It doesn't go away. And then we can use two parentheses for that quadratic, split apart the the x squared into x and then minus 3 and plus 5. So now we have 3 parts to our factored answer instead of 2 like we had in chapter 4. All right, let's take a look at the next one. 2y to the 5th minus 18y to the 3rd. A lot happening here. This is a pretty high ordered polynomial. Let's check to see if there's anything we could take out first. I've got 2y to the 5th and 18y to the 3rd. Both the coefficients are even. That means we can factor out a 2. And y to the 5th and y to the 3rd, the smaller exponent we actually can take out of both of them. So watch this. If we take 2y to the 5th and factor out 2y to the 3rd, that means technically we're dividing. So if we had y to the 5th over y to the 3rd, we would subtract our exponents. And 5 minus 3 is 2. That means we have y squared left over. Okay, minus 2 into 18, that would give us 9. And y cubed into y cubed, that would just go away. There's nothing left for your y variable. And now notice the parenthesis is quadratic. Again, if we treat this like y squared plus 0y minus 9, two numbers that multiply to get negative 9 but add to get 0 in the middle would be positive 3 and negative 3. That means we can split apart that parenthesis into smaller, unfactorable parts by splitting up the y squared and then do a minus 3 and a plus 3, again in either order. And then don't forget to drop that common factor down in front, 2y cubed. That is factored form. Our last example in this row, x cubed minus 3x squared minus 16x plus 48. Notice it's in standard form, so we've got that. But when I look at my 4 terms, there's actually no common factor. And since we haven't factored a cubic expression without a common factor first, we're not totally sure what to do. So let's go ahead and take a look down below and I'll give you some options. Many cubic functions are still factorable without that common factor, but not every cubic function is. This is an option to try when a cubic function doesn't have a common factor to see if we can split it into a product of smaller unfactorable parts. Okay, so here's that x cubed minus 3x squared minus 16x plus 48. The grouping method kind of looks like a times c and split the bx. What we're going to do is just group the first 2 terms and then group the second 2 terms. It kind of looks like what we did before, but it's not exactly the same. We're going to look for common factors now in those smaller parts. X cubed minus 3x squared. We have an x squared in common that we could take out of both of them. If we take x squared out of x cubed, there's an x left over. And then minus 3x squared, if we take the x squared out, we have minus 3 left over. In that second parenthesis, we've got negative 16x plus 48. Remember, we always have to factor out that negative. And now look at 16 and 48. 16 actually is a common factor for both of those terms. When we take out the negative and the 16, it makes that first term, negative 16x, just have an x left over. But here's one thing to remember, everybody. If we had positive 48, but we factor out negative 16, that's going to make it negative, and then 16 goes into 48 3 times. So be careful on watching those signs. And the nice thing about doing this is that we get a match, just like we did before in chapter 4. X minus 3 is one parenthesis, and then we take those parts on the outside, x squared minus 16, and that's our other parenthesis. But hold up, that's quadratic. So that means we're going to have to do x squared plus 0x minus 16. Two numbers that multiply to get negative 16 and add to get 0 in the middle. That's going to be 4 and negative 4. That would separate x squared minus 16 into x plus 4 and x minus 4, again in either order. And then don't forget about that original factor out in front, the x minus 3. So we've actually seen expressions like this where we had to multiply. We're just working backwards now. It's taking it from its standard form and putting it back into its intercept form. All right, you try the next one. See if you can split up this cubic expression by using the grouping method. Once you think you have it, press play and we'll see if we have a match. Okay, how did you do? I have x plus 5, x plus 3, and x minus 3. If you need to pause the video and check that out, just feel free to do that. Otherwise, let's go ahead and move on to that next example. Our final cubic example in this row, x cubed plus 64. Notice it's not fully in standard form. We have terms missing. And when terms are missing, we can't group as a method of factoring. So no grouping possible. But don't worry, I've got an option for you when we have this type of cubic expression. Let's take a look down below. The last part of our notes for 5.4 day 1, special factoring patterns for cubic functions. So the first thing I'm going to do is list out perfect cubes for you. So please listen to make sure you know what these numbers mean. If I had 1 to the third power, that's 1 times 1 times 1. That would just equal 1. 2 to the third power is 2 times 2 times 2. Well, 2 times 2 is 4, and 4 times 2 is 8. From there, 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125, and so on. Get to know your perfect cube values for this section. Now, the sum of two cubes and the difference of two cubes are going to be formulas that, you guessed it, you get to memorize. The sum of two cubes setup is when you have a perfect cube, usually it's your variable first, and then a number that's maybe in that list up above. Notice when you factor, you've got a little parenthesis and then a bigger parenthesis. And that template is true no matter what your perfect cube values are. So here's that x cubed plus 64 that we had up above. It isn't groupable, but notice x cubed fits that first part of the definition. 64 I had up here at the top. So if this is 1 cubed, 2 cubed, 3 cubed, 64 is the same as 4 cubed. So that way we can write or rewrite it as x cubed plus 4 cubed. Then we look at that template. If it's a cubed plus b cubed, we're going to have a little parenthesis for a factor and then a big parenthesis for a factor. The little parenthesis is just that first part without an exponent plus the second part without an exponent. Literally just x plus 4. They're not like terms, so we leave it. And then a squared. So I'm going to take that x and square it. And then it's minus. So here's where it gets a little dicey. It's always minus, and then we always multiply a times b together. So I'm just going to put x times 4 in parentheses. Plus b squared. Well, if b is 4, technically we're going to take 4 and square it. From here, we just need to simplify. It's really easy. That first parenthesis still stays x plus 4. And then x squared, we can just get rid of that parenthesis and write it as x squared. Minus x times 4, no, that's a 4 and not a y. I just want to clarify that for everybody. It's just 4x. And then plus 4 squared, which is 16. Here's what we have to remember. It's so much fun. This second parenthesis will never, ever factor further. Even now, you want to try because it looks like it could. It never factors beyond that point. So the 2 parenthesis rule for a sum of 2 perfect cubes is always your final end result. And last but not least, let's see what happens when we have a difference or when we subtract. When you look at the template, really the only change on the left-hand side is that subtraction in the middle. So we have a cubed minus b cubed, little parenthesis, big parenthesis. And it's a pretty similar template. Notice it's minus here, and then it goes plus and plus. But then we kind of figure out the a and the b the same way we did before. Now in this example, 2m cubed minus 250, what you have to recognize is that m cubed kind of fits the definition, but the 2 doesn't. Notice 2 and 250, we have a common factor. If we take that out, that would give us m cubed, and then 2 goes into 250 125 times. Oh, of course, that's one of our choices up above. That would be the same as 5 cubed. So that means we can rewrite as m cubed minus 5 cubed. As we apply our definition, so I'm just going to write equals, sorry. As we apply our definition, we're going to have a 2 and then a little parenthesis. And in that little parenthesis, it's just a minus b. So in this case, that's going to be m minus 5. And then in the big parenthesis, we have a squared, which is going to be m, technically, squared, plus a times b. And here's where I want to put a little star. Notice a and b, technically they're not negative. Either of them are negative. They're both positive values. This is just a subtraction problem. So when I put a times b in parentheses, it's just m times 5. It isn't m times negative 5. And then plus, again, it's just 5 being squared. So now let's simplify. We have 2 and then m minus 5. Technically that m squared, done. Plus m times 5 plus 5 squared, which is 25. And again, that's as far as that will factor. And this is 5.4, day 1.